What is up, everyone, and welcome back to the series on Python, on computers, and on data science. We're just going to pick up where we left off last time, so it looks like we're working with missing values and quantitative variables, so let's get started. Okay, so email messages have the highest conversion, while contextual ads, let's expand this a little bit, are a bit of a letdown. We could end our analysis here, but a true analyst should know how to work their way around this question. In addition to traffic sources, Google Analytics provides summarized information about users. So you can see they read this table here. You have their device type, the time probably that they spent on the page, etc. That time is spent on the website. It appears as if we have everything we need to analyze the data, but once again we have more missing values. Some users have missing values for their age and time spent on the website. Time and age are quantitative variables. Missing values and quantitative variables are represented with representative values. These values represent the status of the data set selected for analysis. To estimate typical values in the data set, use the mean or the median. The mean is the sum of all values divided by the number of values. It's calculated with the mean method. Remember, it can be applied to either an entire table or an individual column or group data. Let's calculate the average age of the actors who played Hogwarts students. It's interesting why they type in her height if they're talking about the age. Wait, do they say? Yeah, average age, but then they do heights. That's not, they should fix that. To get the mean value, they call the mean method. The median is the middle ground in a data set, meaning exactly half the elements fall above it and the other half fall below it. To calculate the median of the list 30294, we first need to place them in order from smallest to largest. The median in this case would be 3. There's the same number of values to the left and right of this number. With an even number of values, we must leverage the two middle values to find our median. In the set, for example, the middle values are 3 and 4. Their median is the average, which is 3.5. The median method is used, as the name suggests, to find the median. Just like mean, it can be applied to a table or segment of group data. So why do we need the median then if we have the mean? The mean inaccurately represents data when some values are significant outliers from the majority of values. For example, 5 employees at a company have a $10,000 salary. An investor invites a marketing director with a $30,000 paycheck. By what percent did the average salary increase after the marketing director was brought on the board? The salaries for the first employees are entered in the old staff, version in the new staff. By calling the mean method, we can calculate the average values. In order to answer the question of the percent increase in employee salary, we have to divide the new staff configuration by the old staff configuration. This calculates how many times larger the average salary for the new staff configuration is that of the average salary for the old staff. They subtract 1 in order to determine how many percentage points the average salary is increased. And we see that the salary grew by 33%. And just like that, by hiring new highly paid employee, the average salary for all team members increased by 33%. Just like the old joke goes, if John has 10 apples and Bob has 0, the average between the two is 5. When a data set has an outlying values of 30,000 versus 10,000, then it's better to use the median. So let's apply the median to the new director set. You can see it's 10,000. This means that the salary median was 10,000 and continues to be so even after the marketing director joins the team. The median provides more objective information about employee salaries than the average value. Let's analyze user data to find the factors beyond traffic sources that also influence purchase decisions. So let's go. Okay, and this should be the same description that we already read. So we will read from the data file web-analytics.csv and store their values to get the analytics data. Oh, misspelled it. Analytics underscore data equals read CSV, which they say is at datasets / web analytics underscore data dot CSV. And then they want us to calculate the average value of users and save it to the age average variable and then print the results. So let's first print out what analytics data looks like. They fixed it so shift enter works now. Oh, I forgot to import pandas. Import pandas as PD, and this should be pd.readcsv. My bad, guys. Okay, and they want the average age, so we should be able to do, let's keep that print because we're going to need it. Age average equals analytics data at age, and then we want the average, which should be mean, right? And then let's print it to make sure that that worked. That seems about right, so we'll check it. Great, so next. Okay, replace the missing values from the average age. Print the first 10 lines of the data set to the screen. Okay, so we can do analytics, data, age dot fill in A with age average, and then print analytics data dot head, and they want the first 10 values, right? There's still an and in there. We need to do analytics age is going to be equal to, so it doesn't do it in place. Misspelled analytics, didn't I? Let's see. Analytics data. There we go. So age has no nan anymore, and you see it's replaced by this 32 value. Okay, so let's check that. Correct. Next. Search for the average session time on the website and store it to time average variable, then print the results. So this is going to be the same code we wrote for the last one, except we're going to replace the column with time instead. Although I'm not 100% sure that the column was called time, but we'll check it here. Analytics data time dot mean, print time average. That looks about right, so we'll check it. That's great. Users spend an average of 23 minutes on the site. That's quite a lot, but how does the data spread affect the value? You can replace the time with the average value, but try to remember that users can also access the internet from either a mobile or device or desktop computer. Let's take this into consideration to heighten our accuracy when entering missing values pertaining to time spent on the website. Select the table rows with data containing views from a computer. That means the rows in the device type column that display the desktop value. Save the results to the desktop data variable and print the first 5 rows. Okay, so they want us to create a variable called desktop data and set it equal to analytics data dot locate, where analytics data, what is it, device type equals desktop. And then they want us to print the first 5 rows, so that would be desktop data dot head 5. So that looks about right, so we'll check that. Great. So next, find out how much time on average desktop users spend on the website. Store this value to the variable desktop data time average and print it. So desktop, this is going to be the same code we wrote previously. Data time average, it's going to be equal to desktop data at time dot mean, and print the desktop data time average. Which is 1741. Just check it. 29 minutes is more than the total average time, which tells us that users find it easier to explore the website from a computer. Next, retrieve the table with value sessions from mobile devices. So it's going to be the exact same code again. Mobile data equals analytics data dot locate, where analytics data what is it? Device type equals mobile. See if that's right. Hopefully that one's mobile there. They're not as clear as they were earlier. And then they want us to print the first 5 rows, which would be mobile data dot head 5. Okay, that looks correct. We'll check it. Great. More access the internet from mobile device than from desktop. Next, calculate the average time on mobile websites. So this is going to be the same code again. So we do mobile data time average equals mobile data time dot mean, print mobile data time average. Lot less, right? It was like 1200, now it's 40 something. Correct, only 41 seconds. It seems like there might be some bugs in the mobile version that have to be reported. If nothing is done to remedy this, the big investor will be disappointed by the outcome of investing big money into increased traffic. Okay, next. You evaluate the performance of Google Analytics traffic sources in addition to identifying the best channel for acquiring traffic in relation to repeated purchases. Let's check out the final values. Emails 73%. Why do they have commas in there? 73%. Contextual ads and other traffic sources produce almost the same results. We should strongly recommend the marketing team that they check out the contextual ad settings and monitor resources as well as their metrics. You studied users' behavior and established that they generally spend more time on the site when they're accessing it via a computer versus on a mobile device. Bring this little tidbit of information to your fellow coworkers' attention and present your conclusions in a monthly project report. Okay, so next. So now we're in the second data preprocessing course chapter. There are different types of data, and some of them are somewhat challenging to analyze. In this chapter, we're going to learn how to convert them in order to make calculations easier. There'll be a lot of practice converting data into different data types. We'll learn how to convert strings into date and time formats, convert strings into numeric values with the two numeric and as type methods, process errors in the try except method, combine tables using the merge method, and figure out which pivot tables are and how the pivot table method creates them. You can save this list and track your progress every day. If something isn't crystal clear, feel free to ask your question in exercise chat or in the YouTube comments, and a community manager on Instructor will be willing to help. There isn't anything in the Practicum course that you won't need to use later, so better take care of things now and resurface the next chapter. Each new chapter builds on the previous one. Okay, so this should take approximately 20 minutes each. Hopefully not that long. Search engine optimization is an action that helps rank websites higher in search engine results. The goal is increase traffic from search engines and boost revenue in the process. A website's ranking could be different depending on the request. For example, Practicum by Yandex is the top result for becoming a data analyst while it comes in third place for a front-end developer course. A website's search ranking depends on a huge number of factors, most commonly categorized into internal and external. Internal factors include the website's load speed and content quality, whereas an example of an external factor is how often the website is mentioned in resources like social media news outlets. But regardless of the factors SEO specialists look at, the first thing they ask analysts how the website is doing at the moment. Now, here's the task you got handed to you. Figure out which product categories and subcategories on the website rank lowest for the search engines. And we need that info yesterday, by the way. So let's go. So how to read Excel files. Okay, so use the read Excel method to read the first sheet in traffic data. Print the first 5 rows using the head method and read the column names. Okay, so remember to read, they say do pd.read Excel. And we feed it the file name, which they should probably mention here at the bottom, which is /datasets/SEO_data_engine.xls. x. Okay, and then they want us to print the first 5 rows. We do print data head 5. Oh, did way too many enters there. That's where auto tab does not come in handy. Okay, so let's print that. Okay, so we see the subcategory ID is the ID for the product subcategory or its cryptid name. The source is the traffic source, which you can see is going to be I think they messed up because it's not actually source, it's like 0, I think, or index or something. Let's check it. SEO data. So they must have a typo here, because here it's called SEO data.xlsx. Down here they want us to read data. Engine. SEO underscore data.xls. Oh, I did it again. Okay, so now you can see they have source and visits. Okay, so they just have a typo here. This should not be ENG. Great. Now I just have to go back and do the rest for the rest of the sheets. Okay, so there's only one traffic source in the first 5 table rows. Direct, check to make sure there are other sources in the source column by printing all unique values from that column. Okay, so we want to, let's do data at source.unique, right? And we probably want to print that. Potentially we could use value counts and it'll tell you how many of each there are, but we'll just do unique because that's all it's asking for. So we see there's direct and organic. If you thought direct was all there are, think again, buddy, because you have organic too. Awesome. Okay, next. So use the read Excel method to read the subcategory IDs as well as the second sheet and save it to the variable subcategory dict. Print the first 5 rows using the head method. Okay, so we want to use save it to the variable subcategory underscore dict is going to be equal to PD. We also need to re-import pandas because they deleted that from our code. Import pandas as PD. We want pd.read Excel. Let's see if they tell us how to read a second sheet. Okay, so slash datasets, and again, I'm going to take off the engine at the end there, ENG, because that was wrong last time. Oh, take it off. Okay, and then the sheet name we want to read is let's see. Do they want us to read the sheet name called subcategory IDs? It did an error. Head 5. Oh. That seemed to work. Let's see. We check that. SEO data.lxs and store it in the subcategory. Okay, so let's not specify the sheet. Wants us to read the one sec, let me just figure this out a little bit, and figured out they have the typo again. So now they do want ENG at the end of there. I guess without ENG, it's like the Russian version. And so I put the ENG there, and then it worked fine. Another thing I figured out while you're doing this is you can replace this sheet name, if you don't know the name of it, to just an index number. So if I wanted the first sheet, I would put a 0 there. If I wanted the second sheet, I would put a 1 there, and so on. But so that answers that question. It's so broken, guys. It's brand new, though, so I guess that's why. Okay, so 4 is read Excel to read the third sheet category IDs and save it to the category dict variable. Print the first 5 rows using the head method. Use the read Excel to finally read the third sheet. Okay, so we do import pandas as PD again, and we're going to do category dict is going to be equal to pd.read Excel. And hopefully it's this one, slash datasets slash SEO underscore data underscore eng.xlsx. And then they want the third sheet, so we'll put the 2 index there. I guess you can also put category dict if you want to put the actual name there. And then, or I guess it's category ID is what the sheet's called. But then we print the first 5 rows. We do category underscore dict dot head 5. Oh, didn't print it. It's annoying they made me retype all that out. I could have just, changed the thing from the previous one. Okay, so we'll check that. Correct. Next. Imperfect data. The data is uploaded and looks up to snuff, but we still need to know the ratio of direct to organic traffic for each category. Let's see how things stand with the SEO by dividing the number of direct clicks by the number of organic ones. Group the data frame by traffic source and count the number of visits. Okay, so... Oh, this is just explaining what you can do here. Okay, so we've got a weird combination of subcategories instead of what we were expecting. Where's the visit total? So figure out why we're unable to calculate the total number of visits. Check the data type using the info method. Okay, so we want to do print data.info. So we can see that they're all non-null objects instead of strings or whatever they're looking for. So check that. For every Pandas thinks that the visits are string values, not numerical values. We'll learn how to straighten that out. I don't even see it say string anywhere on here. It just says non-null object. Oh well. Gotta fix it anyway. It's not numeric, right? So when Pandas reads through data, it automatically converts it into a workable format. However, sometimes things go wrong, and that's where you come in. Let's take a look at a file with a list of payments per purchase type transactions. For each category letter in category column, we'll calculate the total number of sales. So far, so good. The ID column contains transaction IDs. The category column deals with categories of products sold. Additionally, amount is the cost of each product. Let's use the info method to figure out what type Pandas assigned to the column names. So non-null objects. This is suspicious. The ID and amount columns were identified as object strings, which means that there must be some non-numerical values or omissions that prevent our calculations from taking place. Just an example, let's try calculating the total sales. So it returns this unsupported operand, float, and string. Unfortunately, we weren't able to calculate the total because there are string values placed inside the amount column. Take all the strings and make them numerical. Fortunately, Pandas has a standardized method for that, which is toNumeric, which converts column values into a float64 type. The toNumeric method has errors parameter. The errors values determine what toNumeric will do when it encounters a problem with incorrect value. So errors equals raised, default behavior where an error is generated for the incorrect values, blocking conversion to numbers. Coerce means incorrect values are forcibly replaced with nan. Incorrect values are ignored, leaving them right where they are. Converting strings into numeric type when possible isn't the only thing numeric does. It's also great for pinpointing which values are giving the method troubles. One thing to know about numeric method is that the numbers it produces will possess the float data type, and there are values which there are lots of values where this isn't the case. The even better news is that we can get the value types the way we'd like using the as type method. For example, in as type methods, int argument explains that the value must be converted to an integer. Okay, so then wants to convert the string values in the ID column to numbers using the toNumeric method. First run the code and check the result. You'll see it's an error. It's okay. When you look through the error, comment out the line where you have a string conversion. When you look through this, okay, wait. Convert the string values in the ID column to numbers using the toNumeric method. So we do transactions at ID.to_numeric. Potentially you could save transactions ID equals transactions ID.toNumeric. Okay, well, let's see if it gives us an error here. Yep, series has no attribute toNumeric. I don't think that's the error they were expecting. They don't actually show you how to get the whole table, though. I don't know. Let's comment it out and go on. That's not what I got, but okay, next. We'll figure it out in the next part. Change the null to nan so we don't get the same error again. Try converting the string values in the ID column into numbers by using the toNumeric method one more time. So if we do transactions, while only providing the errors parameter with the coerce value. Okay, so transactions ID equals transactions. I wonder if they want us to convert the whole thing. Let's just do toNumeric here and do errors equals coerce. Oh, I know why. It's because I'm not doing pd.toNumeric. I'm trying to convert the actual data frame. So if we do pd.toNumeric here, and we're doing this on transactions at ID, and we want to replace or do errors equals coerce. Okay, looks like it worked. Print the result using the tail method. Transactions.tail. Let's check it. I guess I could have printed that. Print transactions.tail here. Let's see, so it changed the ID to nan. Potentially it wants us to change the whole, let's just change the whole data frame. Nope, it has to be a series, so you have to do a specific column. Maybe we just print the ID column is what it wants. Let's check that. Okay, one sec. The other problem was I was trying to print just the ID column here. It just wanted me to print the whole table, and then also not just tail. It says the final 5 values, so it should be tail 5 instead. But that worked, so next. So after converting the data, call the info method one more time, check to see if the pd.numeric had any type on the values. So we do transactions. I guess print transactions.info. Yep, so now it's a float 64, see? Great, so next. Use the toNumeric method in order to modify the values in the amount column into numbers. Okay, so we do the same thing here. Transactions at amount should be equal to pd.numeric amount, where we coerce the errors into nans, and then we print transactions.info. You can see amount now is float 64, so the last one is it's correct. Next. Calculate the total cost of all items sold, or the sum of the values in the transactions data frames amount column. Okay, so we want to do, it doesn't tell you what you like to store it or to print it or whatever, but we'll just print it, transactions amount dot sum. Okay, it looks right, we'll check it. It isn't just a number. We're actually counting the money someone has earned, collected, or used to pay for something. Calculate the total sales for each category. To do this, you must first group the transactions data frame by the category column. So we do transactions dot group by category, and then call dot sum. They want us to print this. Hit play. Check it. Shocking but true. Calculating totals is way easier when you're working with numbers. Okay, next. Now let's go back to the traffic table and find the total number of visits we just acquired. We just acquired combined category names for the first time, whereas visits column was identified as a strings value. We'd like you to convert the values in the data frames visits column into a numerical type by using the toNumeric method with no arguments. First, run the code and check the results. You'll see it's an error. It's okay. Okay, so we do data visits is going to be equal to pd.toNumeric of data visits. And they said there should be an error here. Yep. Unable to parse 236948. We'll check that. Or we're supposed to comment it out, my bad. Okay. Next. Figure out what's wrong with row 964. Call the Loc method, the one we hope you still remember from the introductory course. It'll take us to the data frame using an index value, in this particular case, the row number. So we do data.locate 964. And they want us to print it. Okay, so check that. Judging by the name of the subcategory total, intermediate tools were added for each source at the time of uploading, and the total value is written in quotation marks for some odd reason. Okay, calculate how many rows there are in the data frame column and print them as follows. Like I say, I get next. So we can just do print number of rows colon comma, and then we're going to put the number of rows, which is the length of data It doesn't say which column to take the length of. Then print the rows in the subcategory ID column that have a value of total. Print the number of rows in the subcategory ID. Print data subcategory ID. Length of data.locate data.subcategory equals total. There's 2 rows ruining it. Is that right? Print the rows that have a value total in the subcategory ID. Okay, so we don't need that then. They just want 2. Okay, one sec. I didn't want us the length of the subcategory ID equals total. It wanted us to actually print the rows. And second thing is I put data.loc here, and it didn't like that. It just wanted data with, even though they're equivalent, it's just that when they're checking the code, they missed that. You could also have .loc there. But so let's try and finish this up. We're going pretty long here. So we'll do the last 2 and be done. So delete the rows with a value of total in the subcategory ID column data frame. Check the results. Okay, so delete the rows with the value of total in the subcategory ID. Okay, so we should be able to do remove, right? So data equals data dot remove data dot locate data subcategory ID equals total. So you can't remove like that. Okay, so let's see. Let's see if it tells us how to remove up here in the... Nope, it doesn't tell us how to remove. Let's see, remove from... Remove Pandas row. Dot drop, I guess, is what they want. They didn't teach us that, so it's kind of interesting. Okay, let's just do data dot drop. Maybe we just want the condition here, data equals total. This is probably square brackets, not parentheses. Let's see. Let's go back to what we had before, but put square brackets instead. Okay, one sec. Use drop because we haven't learned that yet. It wants us to just, do this condition where it's not equal to total. So we're going to grab all of the data in the subcategory ID where it's not equal to total, and then just print, and we get nothing because we already deleted that. Okay, so go next. So 11, change the data type for visits column to integer. Check to see what happens. So they told us how to do this. We use as type, right? It's at the bottom here. Yep, so we do data for column visits dot as type int, and we need to, since it's not in place, we need to do data visits is going to be equal to data visits as type integer, and then print the info methods. We do data dot info. And we can see visits is now int64, so we check that. Correct. Next. Group the data by source and calculate the number of visits for each one, then print the results. So we group the data by source. So we do data.group by source and calculate the number of visits for each one. So that's probably just count, right? And it wants us to print it. See if that's right. Check it. Group the data by source and then calculate the number of visits for each one. Oh, then it wants visits, right? Not subcategory ID. Let's check that. Let's just see if we just put visits here. Or if we do count and then get visits. Check that. Didn't want count, it wanted sum, and that was the fix, and that's it. So sorry this video took so long. It would have been shorter if they didn't have so many mistakes in here. So we'll work on Pandas methods next time.